This is a video from section 12.3. The directions say to find the dot product of A and B. Let's take a look at problem 2. Suppose A is the vector 5, -2, and B is the vector 3, 4. The dot product of A and B is equal to 5 times 3 plus -2 times 4. But this is equal to 15 minus 8, which is equal to 7. So the dot product of A and B is equal to 7. And that's how we do problem 2. Problem 3. Suppose A is the vector 1.5, 0.4, and B is the vector -4, 6. The dot product of A and B is equal to 1.5 times -4 plus 0.4 times 6. But this is equal to -6 plus 2.4, which is equal to -3.6. So the dot product of A and B is equal to -3.6. That's how we do 3. Let's take a look at 4. Suppose A is the vector 6, -2, 3, and B is the vector 2, 5, -1. The dot product of A and B is equal to 6 times 2 plus -2 times 5 plus 3 times -1. So that's right here. If I simplify further, I get 12 minus 10 minus 3, which is equal to 2 minus 3, and that's equal to -1. And so, therefore, the dot product of A and B is equal to -1. That's how we do 4. Let's take a look at 5. Suppose A is the vector 4, 1, 1/4, and B is the vector 6, -3, 8. The dot product of A and B is equal to 4 times 6 plus 1 times -3 plus 1/4 times 8. But this is equal to 24 minus 3 plus 2, which is equal to 21 plus 2, which is equal to 23. And so, therefore, the dot product of A and B must equal 23. That's number 5. Number 6. Suppose A is the vector P, -P, 2P, and B is the vector 2Q, Q, -Q. The dot product of A and B is P times 2Q minus P times Q plus 2P times -Q. But that's 2PQ minus PQ minus 2PQ. But notice how the 2PQs cancel, right? Isn't 2PQ minus 2PQ 0? So these two terms cancel, and what we're left with is -PQ. And so therefore, the dot product of A and B is equal to -PQ. That's number 6. Let's take a look at 7. Suppose A is the vector 2i plus 1j plus 0k, and B is the vector 1i minus 1j plus 1k. And I just wanted to remind you what I, j, and k are. I is the vector 1, 0, 0. J is the vector 0, 1, 0, and k is the vector 0, 0, 1. And so if you notice, I'm expressing the vectors A and B in terms of I, j, and k. So it's just another way to express a vector. Now, if I want the dot product of A and B, I'm going to get 2 times 1 plus 1 times -1 plus 0 times 1. and that's equal to 2 minus 1 plus 0, and that's equal to 1. So the dot product of A and B is equal to 1. That's number 7. Let's take a look at 8. Suppose A is the vector 3i plus 2j minus 1k. B is the vector 4i plus 0j plus 5k. The dot product of A and B is equal to 3 times 4 plus 2 times 0 minus 1 times 5. Or you can say 3 times 4 plus 2 times 0 plus negative 1 times 5. It's the same idea. But this is equal to 12 minus 5, and 12 minus 5 is 7. And so therefore, the dot product of A and B must equal 7. Now, what I'm going to do is take a look at number 9. So we got 2 more problems that I want to do for this video, 9, and I want to do problem 10. Now, suppose A, the length of it, let's say it this way. Suppose the length of A is 7, and the length of B is 4. And the angle between vectors A and B is 30 degrees. Now, let's see if we can draw a picture of this. So suppose this is my vector A, and suppose this is my vector B, okay? The angle between these two vectors is 30 degrees. Now we have a handy formula, and don't forget, we're looking for the dot product of A and B. Now, cosine of theta is equal to the dot product of A and B divided by the length of A times the length of B, like so. We don't know the dot product of A and B. We do know angle theta, and we know the lengths of A and the length, let me say it this way. We know the lengths of A and B. So let's see if we can fill in our information. Cosine of 30 degrees is the dot product of A and B divided by, now I'm going to take 7 and multiply it by 4. Now, cosine of 30 degrees is square root of 3 divided by 2. And so this is A dot B, or the dot product of A and B, divided by 28. Now, what we can do is cross multiply. So I'm going to take 2 times the dot product of A and B, right? So I'm multiplying these guys together and these guys together, and then setting them equal. So 2 times the dot product of A and B is equal to 28 times the square root of 3. So if I divide both sides by 2, I get the dot product of A and B is equal to 14 times the square root of 3. And that's how we do problem number 9. Let's finish off with problem 10. Suppose the length of A, or the magnitude of A, is equal to 80. And suppose the magnitude, if you don't mind me saying, of B is 50. and the angle between vectors A and B is, let me use the word is, 3 pi over 4. And so I'm going to do the same thing as problem number 9. Okay? Turns out cosine of theta is the dot product of A and B divided by the magnitude of A times the magnitude of B. So I hope you don't mind me saying magnitude from here on out, okay? We don't know the dot product of A and B. We do know that theta in this problem is 3 pi over 4, okay? So I'm going to write cosine of 3 pi over 4 on the left side. And on the right side, I get A dot B divided by the magnitude of A times the magnitude of B. And I don't know, I like to draw where 3 pi over 4 is located. So here's the y-axis, here's the x-axis. 3 pi over 4 is somewhere over here. And the reference is going to be pi over 4. Okay? Now don't forget, cosine is negative in quadrant 2. So I'm going to take negative square root of 2 over 2, and I'm going to set that equal to the dot product of A and B divided by 80 times 50. Now, 80 times 50 is 4,000, excuse me. So negative root 2 over 2 is the dot product of A and B divided by 4,000. Now, I could still cross multiply if that helps. 2 times the dot product of A and B is equal to 4,000 times negative the square root of 2. So therefore, the dot product of A and B is negative 2,000 times the square root of 2. And that'll do it for this video for section 12.3, and we worked through problems 2 through 10. Okay, thank you.